a yellow piece of paper that looks like this. This yellow piece of paper is what we are going to use to take our notes. As I'm filling this out, you should be filling this out. A lot of this information, especially at the top, is review, so this should be quick. It says a scatter plot shows the relationship between two sets of data. Remember, when we have two sets of data, we call that data bivariate. Remember, you're filling this in. A blank is where data seems to be gathered around a particular value. So anytime that we have data or data points that are gathered together, we call that a cluster, which we've been talking about since we started scatter plotting. If points on the scatter plot are clustered together along a straight line, they have a linear association. An association is the same thing as a correlation. So if your dots cluster around a straight line, or they create a straight line, we call that linear because it's straight, so it's linear. And then we've talked before that a linear association, same thing as a correlation, can be either positive or it can be negative. If I'm moving too fast, you can always pause the video. Also take note that if there aren't any clusters and the data is just randomly everywhere, that's when we have the no association or the no correlation. If you look at the examples below, the first picture that you see has a straight line, and it's going downward, or it is negative. We would call this a linear association because it's creating the straight line, which makes our trend line. And the second picture, if you were to draw a straight line, it wouldn't represent the data. My trend line would look more like this. Since that is not a straight line, we would call that nonlinear. Very similar to when we talked about linear and nonlinear functions. Again, this is not a straight line, so we would call this nonlinear. If the line is straight, linear. If the data is creating a not straight association, it is nonlinear. We've already talked about types of associations. You should know this. Easy peasy. This is a positive. This is no association. Same thing as correlation. And this is negative. All three of these, well, this one and this one, we would call linear. The middle one isn't linear because it didn't create a straight line. At the bottom, it says blank are values that are either much greater or much less than the others in the data set. These points are considered outside the cluster. So when you have those data points that aren't by anything else, you would call that an outlier. And really, this isn't even much of an outlier over here. But we've talked about outliers before. So the big takeaway from the front of this is just to remind you that associations and correlations are the same thing. When your data is clustered together and it creates a straight line, that means it's linear. If your data is clustered together and it doesn't make a straight line, then we call that nonlinear. So can you look at your correlations or associations and determine if they're linear or nonlinear? Okay, flip your paper over. Good morning, good afternoon, depends on when you're watching this video. Today we're going to take notes over using trend lines. You should have already done your problem of the day for today. If you have not done that, make sure you do. Also, don't forget that you were supposed to already have turned in your two-way table project. For some reason that hasn't happened, you need to make sure that that gets done today as well. You should have in front of you a page. Excuse me. On the back, we're going to continue talking about what we can do with our trend lines. So if you have a linear association, so we're going to fill this in with linear association. You can use the line of best fit. Remember, line of best fit is the same thing as a trend line. I guess I was supposed to write that here. Duh. To make predictions. And really the whole point of a scatter plot, or the whole point of drawing trend lines on your scatter plot, is because it helps us make predictions. These next two words that we're going to write down are fancy words, big words, but important words. So anytime we're predicting inside the data range, that's something called interpolation. Yes, that's a big word, interpolation. But I always think of in or internal. It's inside your data range. So I'll give you examples of what that looks like in a second. And then if we're going to make predictions outside of the data range, we're going to talk about extrapolation. And I always think it's extra because it's big, outside of our data range. So what does that mean by inside versus outside data range? If you go look at this first scatter plot, which is talking about beach visitors, my data range is talking about average temperatures, and it looks like it's mostly between 80 and 96. So if I wanted to make a prediction about how many visitors would be at the beach when it's 45 degrees, 45 is not going to be on my graph. So since it's not on my graph, it's extrapolation. If I was making a prediction about what the temperature is at 88 degrees, well, 88 is on my graph. So since it's on my graph, we would call that interpolation. Generally speaking, when we're doing interpolation versus extrapolation, interpolation is more dependable, reliable, and accurate because we're talking about data that we've actually collected and know about. If we're extrapolating, we're making an educated guess based on our trend line. So you'll use your line of fit or your trend line plus its equation to make predictions about either data inside or outside your data range. So the first example is talking about beach visitors, daily temperature, and then visitors that are there. So what's the temperature at the beach, and then how many visitors are there. So notice how it says that we're going to be using the trend line. It doesn't ask us to write an equation. It's really important that as you're working today and tomorrow, you actually read what it's asking you. Sometimes it's going to say use the line. Sometimes it's going to ask you to use the equation. So, question A says, based on the trend line, how many visitors would you expect the beach to have if it were 80 degrees outside? We had this conversation yesterday, but I want to remind you. Once we draw this trend line, we only care about the trend line. All the other data points no longer matter. We're only looking at the trend line. So when I'm making predictions off the line, not making predictions off of dots that are around the line. We're only looking at the line. So it's talking about 80 degrees. So if I were to draw a line up to where the line is at 80 degrees, which it's just barely there, and then draw a line over to the y-axis, I would say that at 80 degrees, there's about 75 visitors. Again, we're making predictions. So if you told me 74, you're not wrong, as long as we're close. So about 75 visitors. Make sure you're labeling. Next it says, what about if it was 90 degrees? So again, I'm going to go to my graph. It looks like they're counting by 2, so this is 90. I'm going to go up and try and keep my line as straight as possible. I know this graph doesn't have very good lines. And then I'm going to hit the line. Once I hit the line, I'm then going to try and draw a line over to my y-axis that is as straight as possible. At 90 degrees, and I might be a little off here, I'm going to go with somewhere between 375 and 400-ish. Again, my line might not be super straight, so if yours is closer to 450, that's fine. I'm going to say about 400 visitors. It's hard for me to draw straight lines on here. And then it says, what if it was 98 degrees? Now, 98 degrees isn't on our graph. And if it was, it would be about right here. So if I extended this trend line out and I drew my line up, I would say that it's off my graph. But I can kind of keep going and I can say that I'm going to be over 600 visitors. Or I could say that it's probably going to be about 625 visitors. Again, this would be an example of extrapolation. It's much harder on C to figure out what an accurate answer is because the graph doesn't go to 98, so we're kind of just guessing. Again, make sure when you're drawing your lines, if you want to use a ruler to try and make it as straight as possible, that's important. Because I feel like B, I was off a little. It might be closer to about 450. As long as you're close, that's all that matters. Again, once you're using your trend line, you're no longer caring about dots. I'm caring about my line. All right, moving down into your last example for these notes. So notice how this time we're going to be using our equation of our trend line to make predictions. So again, a difference. First section, we were using the scatter plot and trend line. Second section, we're using that, but we're actually going to use the equation that it gives us. So, couple of things here. If it's asking us to make a prediction, then we're going to use our equation. That's super, super, super important. It already gave us our equation, so that's great. If you don't like that this is a fraction and you want to rewrite it, you could rewrite it and tell me that your equation is about 1.57x plus 58. Or you could leave it as the fraction and type that in your calculator. Either way, doesn't matter to me. Okay, so A and B are the parts that we really struggle with, and we're going to keep practicing this tomorrow. But part A says, interpret the meaning of the slope in the equation. So it's talking about graduation rates since 1998. So it's 5 over 3, or we talked about how it's about 1.57 is your slope. Doesn't matter which one you want to use. The big thing is that the top number, your 5, is your Y. And Y's, we said, was graduation rate. So 5 is your grad rate. And then 3 would be per year. So if I was going to write this out, I would say that my graduation rate is going to increase 5% every 3 years. So you could say, I'm going to write this down here because I ran out of room, that your grad rate increases 5%, and I know it's percents because it's labeled percents, per 3 years. If you wanted to know what it was for 1 year, that's when you're going to tell me that it's 1.57% per year. And I just got that by dividing. So that's how I interpret my slope. I think about what my variables are. Since 5 was my grad rate because it was my Y, 3 was my X, which was years. So every year it's going up about 1.57%. B says, what's your y-intercept? Well, it doesn't quite hit my y-axis, but I'm going to kind of keep it going, extend my line. It looks like it's going to cross just past 60. But again, we didn't need to do that because we already have our equation. And our equation tells us that our y-intercept is 58. So our y-intercept is going to be that our graduation rate is 58%. The big question is, when is it 58%? Well, remember, your y-intercept is always at 0. But in this case, your y-intercept is at, your 0, is 1998. So that means that your graduation rate was 58% in, I guess it's not at, it's in 1998, because that's when your graph started. Again, A and B, you're going to see today. You're going to have to tell me what the slope means, tell me what the y-intercept means, but we're going to practice that again a whole bunch tomorrow too. All right, so now we're going to make predictions using our trend line. So it says, predict the graduation rate in 2020 or 22 years after 1998 using the equation. This prediction an example of interpolation or extrapolation? So I'm going to use my equation, and it's talking about graduation rates or graduation year because it's talking about 22 years after. So I'm going to use the equation that it gave me. Don't do anything else. So I'm going to say y equals 5 over 3. Since I want to know years and years is x, I'm going to replace x with 22. Why did I use 22? Because that's what it told me, or it's been 22 years since the graph started. And then we're going to add 58. All you need to do is take your calculator and type into your calculator 5/3 times 22 plus 58. Type that into your calculator. I got a great big long decimal. I'm going to round it just to the nearest whole number. So I'm going to say 95%. Where did I get percent from? Because that's what my y-axis is labeled, and that's what we were solving for. So that means in 2020, your graduation rate would be 95%. It asked us if this was an example of interpolation or extrapolation. Well, 22 years isn't on my scatter plot, so that means it's outside my data range. So this is an example of extrapolation. Going on to D. D says, predict the graduation rate in 2005 using the trend line. Is this prediction an example of an interpolation or extrapolation? Using the equation of the trend line, sorry. So 2005. 2005 is the year that we're looking at. In 2005, we have to figure out how many years that is since 1998 because that's what our graph is talking about. So again, we're going to use our equation. We have to plug a number in for x and then add 58. Now, when I do this, I'm going to start counting since 1998. So if I do that math, 2005 to 1998, that's 7 years. So I'm going to put 7 here. I'm going to do my math. Same thing as before, typing into my calculator, 5/3 times 7 plus 58. And I'm going to round that up to 70. So my graduation rate in 2005 would be 70%. Then it's asking if it's interpolation or extrapolation. Well, 7 is on my graph 7 years after, so that is an example of interpolation because it's inside my data range. If I wanted to double check myself, theoretically, when I go and look at my trend line and my equation should give me about the same answer. So if I wanted to check myself, I should go to 7, go to my trend line, and then go across. And I'm pretty much right at 70, which is what we predicted. So we just have to be careful in reading. Are we talking about using the trend line, or are we talking about using the equation of the trend line? Either way, you should get about the same answer. It's important that if you're using your equation of your trend line, like we did on C and D, that you're showing me work. All right, you should have gotten your assignment for today, which it says exploring trend lines. Let's go ahead and look at that. And let's do a couple of these together. So I'm going to start with number 1. We'll do 1 together. It's really important that you read what it's asking you, because if it says use the trend line, you don't have to use the equation. If it says use the equation, you need to use the equation. So it says write an equation for your trend line. Hopefully by this point you've done this so many times you're tired of talking about it. When I look at this graph, I need to come up with 2 points. Remember, we don't care about the data points, just 2 nice, pretty points that we can use to write our slope formula. So I'm going to start with this point. Yes, I know there's a data point there, but that's at the point 2 and 20. And then I'm going to also use, I think I'm going to use this, which looks like it's at about 4 and 40. I hope that's really accurate. It's hard to see this kind of on my iPad. Once I found my 2 points, I'm going to use them to find the slope of my line. So these are my y values. So I'm going to say 40 minus 20. And then I'm going to say 4 minus 2. Again, you should be super good at this. And I'm going to end up with 20 over 2. That's nice because 20 over 2 is 10. I like that. When I look at my y-intercept, it looks like I'm crossing the y-axis at about 0. So I'm going to say that my equation is y equals 10x, and then I'm not putting plus 0, I'm just going to call it good. So that's the equation for my trend line. It looks like it's talking about distance traveled and then the time it takes to do it. It says use the trend line. Notice how it doesn't say equation, it says use the trend line. So since we're just using the trend line to predict how many miles were traveled after 30 minutes. So 30 minutes looks like it's right here. So I'm going to go across, trying to make that as straight as possible until I hit the line. In that case, it does look like there's a dot there, but remember, we don't really care about dots. We're using the line. And then if I go down, it looks like I'm at about 3. So I would say it would take about 3, or if you've been traveling for 30 minutes, you would have traveled about 3 miles. I'm guessing you're not driving a car. That's not really specific. So that's an example of what you're doing today. Again, make sure that you are reading carefully what it's asking. If it's asking you to use the trend line, use the trend line. If it's asking you to use the equation of the trend line, then you're going to use the equation of your trend line to make predictions. When you're done with this assignment, you can turn it in. If you have questions about it, keep it, and I will answer them tomorrow, and we'll actually probably go through and grade it tomorrow. In addition to that, you need to be working on when you're done. So first thing is you need to finish your Exploring Trend Lines worksheet. Then, and all of this is on Google Classroom, so if you want to go read it on Google Classroom, you can. You need to turn in your celebrity scatter plot worksheet. Make sure that you finish the bottom 3. Most of you, a handful of you turned this in yesterday, but there were 3. Write the equation for the trend lines on that. You need to do that. Then on Friday, you had a worksheet where we were making scatter plots, and we did practice 2. You're going to do practice 1 where you're making the scatter plot. That's the worksheet that we did where it was talking about the price of cookies. So you're going to do practice 1, and it's over scatter plots. I'm not exactly sure the exact name of it, but you got that on Friday, so it should be in the front of your math binder. If for some reason you weren't here on Friday or you lost it, see the sub. They have extra copies of it. Then once you're done with all of these, remember we're turning these into the tray. On Google Classroom, I have put a quizzes. This quizzes is a review of the entire unit, and it is going to be due by the day we take the test, which I believe we did for the last unit as well. So it's a big quizzes, so you might be able to work on part of it, but not all of it. And again, it's due the day we take the test. And yes, I'll be taking a grade on it. So make sure that you're working on that if you have free time. If you don't get to the quizzes today, not a big deal, because again, this isn't due until the day we take the test. These first 3 things should be done and turned in. So as soon as you're done watching the video, you're going to work on your Exploring Trend Lines. Again, when you finish stuff, turn it in, be good for the sub, and I will see you all tomorrow.